In this video, I want to look at the relationship between the shear force and the bending moment. So to do that, we're going to go back and look at an old example. So this is example 1C that I would have gone through some videos before. And when we looked at this example, we came up with the shear force and bending moment diagram. So we did the calculations and we came up with a diagram. So what I'm going to do now is just look at this shear force and bending moment diagram. So the first thing, let's look at the shear force here. So let's look at this area. If we looked at the area enclosed by the shear force, so from this is 0 to 1, and the shear force here is minus 30. Okay, so that area here is minus 30 multiplied by 1, which is minus 30. And that works out to be, and these are all in K, right, minus 30K. And that works out to be what the bending moment is at that point. It's minus 30 kilonewton meters. Okay, so what if we take this point here? Okay, so the shear force along here is 26 kilonewton. So if we just take this area here, well, that's 2, that's 1, 2, and 3. So that distance is 2 meters. So the area here is 26 multiplied by 2, which is 52. So that's plus 52. And we add this to our minus 30. We get 22 kilonewton meters, which is what that value is there. So I hope you're beginning to see that the bending moment is the sum of the area enclosed by the shear force. Let's look at another one. So at this point here now, this is 3 meters. So from there to there is 3 meters. And it's still 26 kilonewtons. So that works out to be 78 kilonewton meters. And this is still minus 30. So 78 minus 30 is 48. So if we look at the bending moment at this particular point, it's 48 kilonewton meters. Okay, and we'll look at one more. So if I look at this point here, so that's between 4 and 5, so that's 1 meter, and it's 24 kilonewtons, so that's minus 24 kilonewtons. So our bending moment will be, minus 30 plus 78 minus 24, and that's plus 40, that's 24. Which is exactly what it is at this point here. Okay, so we can see that the bending moment is equal to this area enclosed by the shear force. And a way to write that mathematically is the bending moment, well, the area under the curve is the integral of the shear force. We'll say dx. This value here is x. So the bending moment is the area of the area under the shear force curve. And we'll be using this later on to derive some formulas.